morning, ladies and gentlemen. I think the previous speakers, LT, UI, and Carlos talked about the big picture of getting water, right? How to get the water in. So being an engineer, I'm a bit more down to earth, focused on details. So I'll wrap up today's presentation by sharing with you what engineers have contributed in getting safe water from source to tap to you. So water treatment is a big topic, okay? Although I might talk about just filtration, desalination, and so on, I think it's better to understand what's in the water first before we look at the technology. So I'm trying to do a quite ambitious topic today, but I try to finish in 20 minutes. So I start my clock counting. Okay, so what we look at is to look at a brief history of water treatment, and then what's in the water, how do we treat it, and what do we look in the future, and then some conclusion. A brief history of water treatment. Actually, the diseases have been looking at the water quality, right? Taking care of water back in the 17th century. If you look at the filters, that was developed in the 18th century, middle of the 18th century, about 250 years ago. That is essentially the same filter design principle that we use today, okay? And the first reported major case of cholera, 19th century, and virus detected the early part of this century. In about 1930s, we think that everybody's getting safe drinking water, so in the next 20, 30 years, the development is basically to improve the treatment technology. How can you get a better water at a cheaper price? But all of a sudden, 1974, we found that the treatment process can actually produce carcinogen in our drinking water, which is quite alarming. And then in 1993, there's a major water outbreak, waterborne disease outbreak in Milwaukee, in the United States. That caused 54 deaths and over 700 illness. Right? They identified another parasite called Cryptosporidium angina. Okay? So as a result of that, we are now moving into the age of advanced water treatment, using membrane, ozone, and UV to help us get the water safe. Okay, let's look at what is in our raw water. We get our water from river, lake, groundwater. We try to put it in a reservoir. The reason is that we want to get a safe storage, right, both in terms of quantity as well as quality. But in water, we have a lot of organics, inorganics, and biological matters in it. What are the organics, inorganics? Basically all the minerals. Organics, basically all the dead prime animals. Today, we've got a lot of industrial pollution. So they got the synthetic organics, benzene, for example. Right? And on top of it, there's a lot of microorganisms in water. Some of it actually supports the growth of the marine environment. Okay. So in getting a safe drinking water, we've got to deal with these three big classes of substance. Okay, when we get water, look at the river, get a tap, the first thing we do is to put it in a cup, see how dirty it is. Okay, this is a raw water sample taken at a certain time. We look at what we call it the turbidity, which is a unit of measuring how dirty the water, how dirty does it look. 8 NTU is a pretty good raw water. Normally for filtered water, we got about 1 or below NTU. Okay. Carlos showed us the picture of the river basin with all brown water. You go to water. I expect that water to be in the order of 200 NTU plus. Okay. So, in fact, the turbidity in the water is caused by the particles in the water. And actually, these particles, although it may not be seen by the naked eyes, okay, it actually carries a lot of substance in it. And in the water treatment, we need to get rid of it, basically. So, having given a very, very general, simplified overview of what's in the water, we then look at how to retreat our water. Primarily, most places like Hong Kong, they follow the WHO guideline on drinking water. That's an organization comprising about 100 countries. They all agree to certain standards. And the key philosophy in the water treatment is that we have to rely on the multiple barrier because health is so important. Okay, Singapore is an exception because of the political situation. Singapore relied on new technology recently. Okay, membrane, getting the water from the barrage project, go through this high-tech treatment and then put it to use. Okay, so the single barrier basically. So if anything wrong with the technology itself, then the people taking the water will be subject to a pretty high risk. Okay, so now what we normally do is to put the water in the reservoir first, put it there for a few whatever time needed. In the reservoir, there's certain self-cleaning process in place, and as well as some dilution. So even if the water can be a bit diluted, but through this process, it will become better. And then after that, we take the water from the reservoir to the treatment works. And through the treatment process, we normally have at least 2 processes to do. I mean, obviously in Hong Kong, there's some treatment works built in the 1940s. They don't have this 2-level process. But for those treatment works, the water resources is pretty good. So the risk is very low. LT mentioned about the split of local catchment and Dongjiang water. I put one set of figures, but obviously it can be 20, 80. So the range is between these 2 numbers. In Hong Kong, we have a number of big reservoirs. So basically, High Island, Shek Peak, Tai Tam, Kowloon, and Everything Group, these reservoirs only takes the local catchment water. So what it means is that when it rains, the water is being collected and then put in the reservoir. They are not diluted by other sources. Okay. With all this water coming from Dongjiang, somehow it has to be stored. Not every drop can be used immediately. So Tai Tam, Tam Chung, and Shing Mun, they take both local catchment water as well as a mix of Dongjiang water. Whereas Provo Cove, one of the biggest reservoirs in Hong Kong, the major source is from Dongjiang. Okay, so a lot of treatment works, because of good quality water now we're having, they treat the water from Dongjiang direct. Take Sha Tin treatment works as an example. That's the biggest treatment works in Hong Kong. It's treating about 40% of the supply at present. Previously, it was about 50%. So with the building of more treatment works, we try to put the load off Sha Tin as a kind of risk mitigation measures as well, because we don't want to put all the eggs in one basket. Okay. So talk about the water treatment. Obviously, we need to know what to treat. With Dongjiang being the major source of water, so we need to look at what is in Dongjiang water. All right. For engineers in Hong Kong, water engineers in Hong Kong, we are lucky that we basically look at 5 key parameters. We're not saying that the other parameters are not important, but what I'm trying to say is that if we can deal with these 5 parameters, we can actually deal with the rest already. So these are the 5 parameters we focus. DPP formation, that's a carcinogen that I mentioned about. We try to add chlorine to organics. That's the chance where carcinogens are being formed. Ammonia is from pollution. Okay. Manganese is primarily natural occurring in source water. Unless it's very high concentration, okay, it's not going to cause any health issue. But it causes a brown color in water, which is no good in looking at it. Turbidity comes from the particles, time of the year. Say in summertime, when you have all this heavy rainfall, you've got to run off, so the turbidity tends to be higher. In winter, when you're just getting water from Dongjiang or from Provo Cove Reservoir, then you've got most of the solids settle out, so you tend to have a lower turbidity water. As a result of the Milwaukee outbreak, there's a new requirement in Hong Kong to build all the treatment works with a facility to provide the 4-lot removal of